third installment for putting a function into a power series. We talked about if we can algebraically manipulate it, great, we got that taken care of. For number 2 and 3, we took the derivative to put it in the form that we want. You're great, we got that taken care of. Now let's talk about 4 and 5. With these, we need to integrate to put it into the form that I want. Okay, so let's go ahead and take a look at number 4. I want to find the power series of 1 over 1 minus x and the whole quantity is squared. What you're going to do with these is we're going to integrate this function first. I'm going to take the integral of that function, and that way I can put it into the form that I want, and once I have it in the form that I want, power series, and we'll take the derivative to go back. Okay, so the integral of this function, it's a relatively simple u sub. U would be 1 minus x. And what you would do is you'd come out to negative 1 over 1 minus x after taking the integral of this function. You can go ahead and check with the u sub. Okay, this is basically already in the form that I want, which is great. So what I'm going to do is I'm going to find the power series of negative 1 over 1 minus x. Already got the 1 on top, already got the 1 on the bottom left, already got the minus. Cool, finding the radius and interval is going to be nice. Absolute value of x less than 1. Great. There's your radius. And as for your interval, it's just negative 1 to 1. Great. So we get our radius, and we have our interval. So now let's find the series. So this is going to be the sum, 0 to infinity, of just that x to the n. Now notice I have that negative on the outside. Just put the negative on the outside of the series. That is not, let me say this several times, it is not negative 1 to the n. You're not raising that negative to the n. That negative is simply on the outside. So it's just negative in the sum of x to the n. Cool. And what we've successfully done, we've successfully found the power series of negative 1 over 1 minus x. So what I can do is I can replace that function with that power series. So, replacing negative 1 over 1 minus x with the power series, this is equal to that series, so this is just going to be negative sum from 0 to infinity of x to the n. Great. So, the integral of 1 over 1 minus x quantity squared is equal to this. And so how do I go back to the original? We take the derivative. Okay? We're just simply going to take the derivative of each side. And take the derivative of each side. So taking the derivative of each side, the derivative of the integral goes back to the original 1 over 1 minus x quantity squared. And this is equal to, okay, here's something I want to mention. When you take the derivative of the power series, it's going to be negative. Sum, you add 1 to the bottom. This is now n equals 1 to infinity. And when I take the derivative of that, it's just n x to the n minus 1. And that could be our final answer. This actually is the correct answer, okay? But when you take the derivative of a power series, you always add 1 to the outside. So I'm no longer starting at 0. I'm starting at 1. And notice how I just took the derivative of the inside like normal. Now this is a correct answer. This is absolutely correct. If this is a workout problem, full credit, great job, you're done. But what if it's multiple choice? Sometimes if it's multiple choice, they're going to have all their answer choices starting at 0. That's okay. Let's talk about how to manipulate series whenever changing the outside. How do I do that? How can I make this series, okay, equivalent to this one, whether I start at 1 or start at 0? Well, whenever you subtract 1 from the outside, you are going to add 1 on the inside. So what's going to happen is I'm going to basically change every n with an n plus 1. So this is going to become n plus 1 x to the n. Okay? And these are equivalent series. Why? Let's take a look at this. When I plug my first term into here, when I plug 1 into here, what I need is I need a 1 x to the 0, because 1 minus 1 is 0. So as long as my first term is 1 times x to the 0, we're good. So that's why whenever I subtract 1 from the outside, I need to add 1 to the inside to make up for that. Because now, watch what happens when I plug 0 into here. I get 0 plus 1, which is 1, x to the 0. And it would work throughout. So the big thing is, whatever you do to the outside, just do the opposite to the inside. Period. But both of these are correct answers for 1 over 1 minus x quantity squared. And then finally for number 5, it's the exact same thing. For number 5, or exact same thing as number 3. For number 5, I have x over 1 minus x quantity squared. You're simply just going to put an x times the power series of 1 minus x quantity squared. So depending on which one you want to use, both are correct. That's the thing, they're both the right answer. So this can be x times, if you do it into the first one, it's a negative sum from 1 to infinity of nx to the n minus 1. If you distribute that x into there, your final answer will be the negative sum from 1 to infinity of nx